Thanks for the introduction, Jeff. Aloha and good morning. Thanks to everyone for attending the session. I'll speak this morning about a Pixie-funded project that resulted in the world's most recent climate model-based projections for the world's coral reefs for two key threats to coral reef persistence, particularly as coral-dominated systems here in the Indo-Pacific, and those threats are ocean acidification and thermal coral bleaching. I'm speaking this morning on behalf of both myself and my friend and colleague Ruben van Hooydonk, who works at NOAA AOML in Miami, Florida. Ruben couldn't be here today. He worked very closely with me on this project, and he produced the climate model-based outputs that you'll see in the slides that follow. First, for the non-reef specialists in the room, I'd like to very quickly review coral bleaching and ocean acidification. Corals live in partnership with single-celled microscopic algae called zooxanthellae that reside within coral tissues in very high densities, 1.5 between 1 and 2 million of these are in coral tissues per centimeter squared. The algae give corals their bright colors, and they perform photosynthesis, which provides corals with sugar as food, and in exchange, the corals provide the algae with a home. Normally, this relationship works phenomenally well, and corals, as we know, appear throughout a lot of the world's tropics in shallow, clear waters. However, under high sea temperatures and high light, the algae begin to produce compounds that are toxic to the corals instead of the sugars that the corals need and are accustomed to, and as a consequence, the corals expel the zooxanthellae. Later, the coral's white skeleton becomes visible through the transparent tissue, hence the name coral bleaching. And if stressful conditions persist, bleached corals can die. They don't always die, but bleached corals can die if stressful conditions persist for a couple of weeks, as little as just a couple of weeks. So what you see here shows bleaching at the colony scale, but spatially extensive or mass bleaching happens when higher than normal sea temperatures occur over a large range of the world's oceans in the tropics, and many corals can and have died. In 1998, during the El Nino year, the world's most severe coral bleaching, roughly 16% of the world's coral reefs are thought to have been lost during that individual year alone. So coral bleaching is a big deal for coral reefs, and it's probably the issue among all of the various threats posed to coral reefs by climate change that has resulted in the coral reef and climate change crisis receiving so much media attention and so much attention from the IPCC. Now, some coral bleaching can occur most years on most reefs. However, the spatially extensive or mass bleaching events that cause mass mortality of corals do not occur every year, at least as of yet. So coral bleaching is an episodic or an acute disturbance. Now, in contrast, ocean acidification is occurring gradually, especially in the world's open oceans. The story is a little bit more complex on reefs, but out in the open oceans, the oceans are carbon sinks. They absorb a little bit more. Scientists argue about the number, but roughly 25% of the world's carbon emissions, and as atmospheric carbon dioxide is absorbed, this dissolved carbon dioxide combines with water to produce carbonic acid, which increases the ocean's acidity, and in the chemical equations that follow, or the chemical reactions that follow, rather, the result is a reduced availability of the carbonate ions that corals need to grow their skeletons, and as a consequence, calcification is compromised, coral skeletons are less dense, and thus they're more susceptible to damage, and they struggle to grow quickly enough to keep pace with other climate change-associated impacts and threats like sea level rise. So I'll speak both about what the climate models suggest right now, climate change and ocean acidification pose for the world's coral reefs over these coming decades. So these are our two key threats. Quickly, prominent coral reef researcher Ove Hoegh-Guldberg published a review 15 years ago in Marine and Freshwater Research entitled Climate Change, Coral Bleaching, and the Future of the World's Coral Reefs. And as of last Friday, I believe this to be the world's most cited coral reef publication at 2,246 times. So this paper, maybe more than any other paper, pushed the coral reef and climate change plight to the forefront of the media's attention and to the attention of the IPCC. And in this paper, Alex Timmerman, who may even be here, he now works at the University of Hawaii, he worked with Ove and provided climate model data from 4 different climate models, and what they showed for 4 locations and from these 4 models was that bleaching events were projected to occur annually, so 10 times per decade is what the graph is showing, for these locations by 2050. This resulted in a very general statement in Ove's paper. By approximately 2050, sea temperatures in tropical oceans will experience anomalies every year that will be several times those seen in 1998. Again, that's when 16% of the world's coral reefs were lost just in a single year. And I've brought this up because it was 15 years ago. It was one of the first times climate models had been used and applied in this way to project what the future might hold for coral reefs. Now, interestingly, at least for me and the team that I worked with, despite nearly 15 years passing between 1999 and 2013, no publicly accessible climate model projections were available for coral reef areas as of January 2013 when we started this project. So that meant that no coral reef managers in early 2013, despite how much attention coral reefs and climate change had received in the decade prior, nobody could answer the question that I posed at the top of this slide. What does our current understanding of regional and global climate and projected climate change suggest the future holds for coral reefs in my jurisdiction? Our hope and our aim when we started to collaborate with PIXI was that we could produce climate model ensemble-based projections for coral reefs and make these projections available in a publicly accessible, interactive format. This was good timing because the IPCC and its body of scientists had just released 4 different new emission scenarios, as well as 30 new climate models that were approved for use in the IPCC's very recent 5th assessment report. So early last year, we had an opportunity both to use the RCP scenarios and to use the new climate models. Quickly about RCPs, because it gets very technical quickly, but it's a brief explanation. RCP stands for Representative Concentration Pathway, and each of these pathways defines an emissions trajectory between now, or roughly 2010, and into the 2100s, and a radiative forcing in watts per square meter. That's what the numbers mean. And RCP 8.5, which is shown in red here, assumes emissions growth to be essentially unabated between now and 2100, and this scenario definitely best characterizes current conditions. It will mean, if we continue down our current path, that CO2 equivalent concentrations at Mauna Loa Observatory in 2050 might be as high as 650. So very famously, CO2 equivalent in ppm just surpassed 400 at Mauna Loa in March of this year. So RCP 8.5 formed the focus of our projections because it characterizes current conditions. We also produced projections for the other RCPs, which take a different socioeconomic growth and emissions growth trajectory than RCP 8.5 does. And I'll speak about RCP 6.0 in particular. So we produced 2 publications that contained our projections, and in the first we used a bleaching threshold of 6 degree heating weeks. Briefly, a degree heating week is 1 degree above a baseline temperature, such as an average or an average maximum, for a period of 1 week. And we found globally between 1998 and 2013, 6 degree heating weeks to be an excellent predictor of whether a reef would experience what we called severe bleaching, which we referred to as the reef, the corals resident on the reef, 50% of them being affected by bleaching or more. So with this 6 degree heating week threshold, what the map on the bottom shows is that the median year under RCP 8.5 that the climate model ensemble projects 6 degree heating weeks will be exceeded annually is 2040. What we've shown in orange and blue are locations where that threshold will be exceeded annually up to 5 to 15 years earlier than the median of 2040 and 5 to 15 years later than the median of 2040. We also find there's a couple locations that we call refugia that experience these stressful conditions of 6 degree heating weeks annually as much as 15 or 16 years later than the median of 2040, but these refugia are temporary in nature. So with this ensemble of climate models, the newest climate models, the RCP scenario that best characterizes current emissions growth, 6 degree heating weeks are projected to be surpassed annually at all coral reef locations between now and the middle of the 2050s. Now, briefly, the effect of reducing or stabilizing emissions. So if we made severe and drastic emissions cuts now, such that RCP 6.0 better characterized current conditions than RCP 8.5, then by 2050 at Mauna Loa, CO2 equivalent might be roughly around 500. There is no evidence right now that we can make those kinds of cuts, but if we could, and if we did, then what our work shows with these climate models is that the year in which 6 degree heating weeks would be exceeded annually is only pushed back 2 decades. It's not actually prevented. We don't show the other scenarios because they're even more unrealistic than RCP 6.0 is, but they are inside the paper and they're inside this interactive tool I'll describe later. Later, we updated our work because some felt that 6 degree heating weeks as a threshold was too low. At the 8 degree heating week threshold, intra and interspecies differences in bleaching susceptibility will matter much less. Right now, most coral species will experience bleaching if the reef experiences 8 degree heating weeks during the summer season. So we use this higher threshold, and what you can see is that the way our current understanding of regional and global climate suggests that when 6-degree heating weeks is surpassed or exceeded annually, 8-degree heating weeks are exceeded annually only a few years later. So the general gist or the thrust of our result doesn't change much by changing the threshold to a point at which we believe most coral species will bleach, at least under our current understanding of temperature tolerance. So here we're showing under RCP 8.5, all coral reef locations experience 8-degree heating weeks between 2030 and 2060. What I want you to see, though, is that there's a latitudinal gradient. So the higher latitude reefs are projected to experience these conditions between 10 and 20 years later than the lower latitude reefs. Overall, the histogram of the distribution of our data shows that less than 10% of the reefs are projected to experience 8-degree heating weeks annually later than 2050. So more than 90% of coral reefs are expected to experience these conditions before 2050. We also looked at ocean acidification and calcification. So here we're projecting aragonite saturation state, which is a measure of the ability of calcifying organisms to calcify, and we relate aragonite saturation state to calcification using a conversion rate of 15%, which is an average rate. It won't work for all species, but it was published in a meta-analysis of 30 studies that had looked at the relationship between aragonite saturation state and calcification, and these studies found an average of 15%. So we could project forward what the aragonite saturation state would be between 2010 and the year in which 8-degree heating weeks were projected to occur annually. So at that point, we think a lot of coral species will be challenged annually, so there's a chance they'll be bleaching annually. Conditions will be very stressful for corals. And what we find is that we get the opposite pattern because we're looking at when the temperature stress conditions will occur. And what you're seeing there is that because the temperature stress of those conditions that could result in bleaching occur annually later at the high latitude reefs, those reefs have more time to be exposed to the effects of ocean acidification. And the percent declines in calcification range from 3 to roughly 17% or so between now and when severe bleaching is projected to occur annually. So this opposite latitudinal gradient is the primary result. So the lower latitude reefs are shown in blue, higher latitude are shown in purple, and the time point at which 5% declines in calcification occur is about 10 or so years earlier for the high latitude reefs than for the low latitude reefs, when we're looking at 5% declines in calcification and the year in which severe bleaching is expected to occur annually. We weren't interested in making an assessment of which would be more important for most locations. Rather, we're looking at the interplay between declines in calcification and thermal stress-induced bleaching. And what we're finding is that at least these projections for the current climate models and the current scenarios, we find that there are no refugia from both threats this century. Quickly, we made our projections interactive and publicly accessible. So for all RCP emission scenarios and for all of the bleaching scenarios, for all of the world's coral reef locations, you can view all of that information through a Google Earth KMZ file that's available on the PIXI and NOAA Coral Reef Watch websites. When you open the file, there's an introduction page that describes some of the background that I've provided here and the hierarchical structure of the various projections, which are images, and the images are centered over Hawaii because the work has a strong Hawaii heritage and home. Ruben and I met in a conference room very similar to this one 3 or 4 years ago, and the work has had and continues to have financial support from agencies that have a Honolulu base like PIXI. I'm so wary of making my concluding point that I've crafted it carefully. The newest climate models used in our projections are thought to still slightly underestimate important climate cycles like ENSO, which means our projections might be too optimistic. That's the first point. That said, the reality is that climate models have high uncertainty, and there are numerous covariates that will determine whether and how climate change impacts manifest at the local scale, such as the effectiveness of management actions to reduce stress on reefs that are related to human activity. Also, within our projections, we do not assume that temperature tolerance limits of corals will increase through acclimation and/or adaptation, which is plausible, will vary greatly among species, and is the subject of much ongoing research. Our goal was to make up-to-date climate model projections available for decisions and debate, which we've done, since this information wasn't readily available to anyone previously. Others can now easily use our publicly accessible data to test various scenarios as we learn more about how corals and coral communities respond both to climate change and ocean acidification. You can see our projections and again the tool there. There won't be much time for questions now or during the session that follows, but I'll hang out after the session, and please record my email address so that if you have questions you can get them answered, or if you have interest in any of the data or the images that you've seen. Before I conclude, thanks to Jeff Bridgette, thanks to the Pixie, and thanks to HCA and HCC for the opportunity to speak this morning, and to all of you for attending the session. Thanks.
One quick question. Anybody have a question right now? We have time later, of course. Come on up and get a seat. There's plenty of seats up front. Okay, thanks, Jeff.
By AOML in Miami, Florida. Ruben couldn't be here today. He worked very closely with me on this project, and he produced the climate model-based outputs that you'll see in the slides that follow. First, for the non-reef specialists in the room, I'd like to very quickly review coral bleaching and ocean acidification. Corals live in partnership with single-celled microscopic algae called zooxanthellae that reside within coral tissues in very high densities, 1.5, between 1 and 2 million of these are in coral tissues per centimeter squared. The algae give corals their bright colors, and they perform the name coral bleaching. And if stressful conditions persist, bleached corals can die. They don't always die, but bleached corals can die if stressful conditions persist for a couple of weeks, as little as just a couple of weeks. So what you see here shows bleaching at the colony scale, but spatially extensive or mass bleaching happens when higher than normal sea temperatures occur over a large range of the world's oceans in the tropics, and many corals can and have died. In 1998, during the El Nino year, the world's most severe coral bleaching, roughly 16% of the world's coral reefs are thought to have been lost during that individual year alone. So coral bleaching is a big deal for coral reefs, and it's probably the issue of, among all of the various threats posed to coral reefs by climate change that has resulted in the coral reef and climate change crisis receiving so much media attention and so much attention from the IPCC. Now, some coral bleaching can occur most years on most reefs. However, the spatially extensive or mass bleaching events that cause mass mortality of corals do not occur every year, at least as of yet. So coral bleaching is an episodic or an acute disturbance. Now, in contrast, ocean acidification is occurring gradually. Thanks for the introduction, Jeff. Aloha and good morning. Thanks to everyone for attending the session. I'll speak this morning about a Pixie-funded project that resulted in the world's most recent climate model-based projections for the world's coral reefs for two key threats to coral reef persistence, particularly as coral-dominated systems here in the Indo-Pacific, and those threats are ocean acidification and thermal coral bleaching. I'm speaking this morning on behalf of both myself and my friend and colleague Ruben van Hooydonk, who works at NOAA photosynthesis, which provides corals with sugar as food, and in exchange, the corals provide the algae with a home. Normally, this relationship works phenomenally well, and corals, as we know, appear throughout a lot of the world's tropics in shallow, clear waters. However, under high sea temperatures and high light, the algae begin to produce compounds that are toxic to the corals instead of the sugars that the corals need and are accustomed to, and as a consequence, the corals expel the zooxanthellae. Later, the coral's white skeleton becomes visible through the transparent tissue, hence